Okay, 10.3. So we're gonna go back and we're gonna talk about some things that we talked about before. So I want you to recall two of our definitions, so chord and diameter. So a chord is a segment with endpoints on a circle. And another extra note here is that it divides circle into two arcs, major and minor. Okay? A diameter divides a circle into two semicircles. Okay, so theorem 10.6, congruent corresponding chords theorem. Sorry, it's a lot to say. Okay, so it says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so let's look at this picture over here then. Okay, so I know that arc AB is congruent to arc CD if and only if segment AB is congruent to segment CD. Okay, so that'll help you look at that picture and kind of see what that theorem is saying a little bit better. Okay, theorem 10.7 is the perpendicular chord bisector theorem. It says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so I have a sentence right here, so I'm going to start it over here, but it goes with this picture right here to the right. Okay, so it says if segment EG is a diameter and segment EG is perpendicular to segment DF, then segment HG is congruent to segment HF, and arc GD is congruent to arc GF. Okay, so let's look at this again. If I have a diameter, okay, and it's perpendicular to another chord, then it is cutting that chord in half, okay, and then the arc that goes with that chord is also getting cut in half. Okay, that's what that's saying. All right, 10.8. Perpendicular chord bisector converse. Okay, so we're going to go in the other direction now. If one chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. Okay, so kind of piggybacking basically, right, converse off of 10.7. Okay, we're going to go in the opposite direction. So if segment QS is perpendicular bisector of segment TR, then segment QS is a diameter of the circle. Okay. All right, so looking at example 1, let's do some actual problems here. So in the diagram, circle P is congruent to circle Q, segment FG is congruent to segment JK, and the measure of arc JK is equal to 80 degrees. Find the measure of arc FG. Okay, so I know that FG is congruent to JK, so then that the arcs also have to be the same, right? So then the measure of arc FG has to be the same as the measure of the arc JK, which they told us was 80 degrees. Okay, so the reasoning why is congruent chords in congruent circles, so corresponding arcs are congruent. Okay, turn the page there. Example 2 says, using a diameter, find HK. Okay, so if I'm looking here, I can tell that segment JL is perpendicular to segment HK by theorem 10.7. So HN is equal to NK. Okay, still looking at this picture over here. So then HK is 2 times NK, or 2 times 7, which is 14. Okay, so HK is 14. All right, the next one is find the measure of arc HK. Okay, so I know that segment JL is perpendicular to segment HK. So again, by 10.7 then, I can say that JL bisects arc HK, and the measure of arc HJ is equal to the measure of the arc JK. So 11x is equal to 70 plus x. Subtract x from both sides and you get 10x equals 70. So x is equal to 7. Okay, but it wants to find the measure of the arc, so I need to plug it back in. So 11 times 7 is 77 degrees. And then if I double that, because I want the whole arc HK, you would get 154 degrees is equal to the measure of arc HK. Okay, theorem 10.9 is equidistant chords theorem. So in the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. Okay, so basically what that's saying is that these chords, if it tells you that these segments right here, it's kind of hard to fit it in there. Okay, so if these 2 segments are congruent and perpendicular, okay, they have to be perpendicular to be the closest basically to that segment, or sorry, to the point, the center point, then they are congruent. So if this is congruent, then these are congruent is what that means, okay? But it has to be to the center point. All right, so it says in example 4, in the diagram QR, so QR is equal to ST, which is 16. CU is 2x and CV is 5x minus 9. Find the radius of circle C. Okay, so that's not going to help us find the radius, but it will help us find part of it, okay? So I know that CU is, hold on, sorry, I got a whole thing to write here, I forgot. So step 1, find CU. Okay, so CU, you know that since they are congruent, then CU has to be congruent to CY, okay? So I know that since QR is equal to ST, then CU is equal to CV. Okay, so 2x is equal to 5x minus 9. Subtract 5 and you get negative 3x equals negative 9. So x equals, not 9, sorry, x equals 3. Okay, so plug that back in. 2 times 3 is 6. So CU is 6. Okay, so I'm just gonna basically write over that 2x. CU is 6. Okay, the next thing that I need to do, find QU. Okay, so QU it says because the diameter WX is perpendicular to QR, WX bisects segment QR by theorem 10.7. So QU then has to be half of the whole thing, which was 16 it told us. So QU is 8. So 8, 6. Now to find our radius, we're going to draw radius from C to Q, and we're going to find CQ. So draw it in, okay? Connect it there, and look, I have a radius that I'm looking for, and I know 2 sides of my right triangle. Okay, so I know CU is 6, QU is 8, okay, and the hypotenuse then is obviously x, so 6 squared plus 8 squared equals x squared, 36 plus 64 equals x squared, 100 equals x squared, so that means that x is equal to 10. So CQ is 10, which is a radius, is 10. Okay? And that's all we need for those notes. So let me know if you have any questions. Go ahead and start working on your assignment.